So we are given x plus 1 by x equal to root 2. Then we want to find the value of x to the power 777 plus 1 by x to the power 777. Can we do it? Of course, yes. And we will do it by two different methods. First one, easier one. So we are given once again x plus 1 by x equal to root 2. Let's multiply it by x throughout. So we are multiplying equation 1 by x. To obtain x into x is x square. This x and x will get cancelled. So x square equal to root 2x. Sorry, x square plus 1 equal to root 2x. Now we see that power is decreasing by 1. But we just don't want power to be decreased by 1. We want to compute x to the power 777. That's a big number, right? So let us square both sides once again. Or rather, let's square both sides. So we are squaring both sides. Now we have an expression like a plus b whole thing square. That implies a square plus 2ab plus b square. Right hand side we have root 2 whole thing square, that's just 2. X into x is x square. Oh, we can cancel 2x square from left hand side and right hand side. So you see that you can simply write x to the power 4 equal to minus 1. Wow, quite a simple expression, right? X to the power 4 is simply equal to minus 1. Therefore, what about x to the power 777 then? X to the power 777. Well, let's divide 777 by 4. 4 into 1 is 4. 37. 4, 9 is 36. Remainder 1. 17. 4 into 4 is 16. Remainder 1. So that's equal to x to the power 4 into 194 plus 1. Again by law of indices, this is equal to x to the power 4 to the power 194 into x to the power 1. But as you see, x to the power 4 is simply equal to minus 1. So this is equal to minus 1 to the power 194 into x to the power 1. And that's equal to x to the power 1 minus 1 to the power. Even power is just 1. Minus 1 square is 1. Minus 1 to the power 4 is 1. And so on. Therefore, x to the power 777 plus 1 by x to the power 777 equal to x to the power 1 plus 1 by x to the power 1. Oh. But x plus 1 by x is simply equal to root 2. Therefore, x to the power 77 plus 1 by x to the power 77 is simply equal to root 2. What about other method? Observe that we are given, okay, so second method, we are given x plus 1 by x equal to root 2. Is there any real number that satisfies this equation? The answer is no. If I take x greater than 2, then this quantity is definitely greater than 2, but root 2 is the right hand side is less than 2. If I take x less than 2, then also if it is positive and you get greater than 0, then also 1 by x is greater than 2. So anyway, you can see that right hand side is greater than 2, and similar thing will hold for negative x as well. We cannot take x equal to 0. So whatever value of x you take, it will never happen that x plus 1 by x equal to root 2 as long as x is a real number. So we are bound to say x is a complex number. Further, we observe that we want x to the power 777, a big power. So maybe somewhere we will be using de Moivre's theorem. And yes, we will be using de Moivre's theorem only. So we write x in polar form. So let x equal to r cos theta plus I sin theta. So that's the polar form representation of x. Then 1 by x That's equal to x to the power minus 1 equal to r to the power minus 1 whole thing into cos theta plus I sin theta to the power minus 1. That's by de Moivre's theorem equal to cos of minus theta plus I sin minus theta. We know that cos to be an even function, so cos of minus theta is simply cos theta, and sin to be odd function, so sin of minus theta is minus sin theta. So r to the power minus 1 we write as it is. Cos of minus theta is simply cos theta. Sin of minus theta is minus sin theta. Therefore, we are given x plus 1 by x equal to root 2. Let's write it that. X equal to r cos theta plus ri sin theta. We simply multiply by r. Plus 1 by x equal to r to the power minus 1 cos theta. Oh, I forgot I here. Minus r to the power minus 1 into sin theta, and that's equal to root 2. Now, when we have complex number, we have real part, that's r cos theta and minus 1 by r sin theta, and imaginary part, that's equal to ri sin theta plus r to the power minus 1. Oh, I made a mistake. Once again, we are multiplying r cos theta plus ri sin theta, that's correct. Then r inverse into I. So real part is r cos theta plus r inverse cos theta. Imaginary part is ri sin theta plus r inverse into I sin theta. Now, if two complex numbers are equal, then real part must be equal to real part and imaginary part must be equal to imaginary part. So, we can say r cos theta, that's the real part, plus r inverse cos theta equal to root 2, and imaginary part. Remember, root 2 is root 2 plus 0 times I. So, if we compare the imaginary part, r sin theta minus 1 by r sin theta equal to 0. But sin theta cannot be 0, because if theta equal to 0, then x will turn out to be a real number. If theta is 0, then x will turn out to be a real number, definitely. But we don't want x to be a real number, as we have seen. So theta is not equal to 0. So if I take sin theta common, then r minus 1 by r equal to 0. I cannot have sin theta equal to 0 either, then x will turn out to be a real number. So I am bound to say 1 minus 1 by r equal to 0. So r square equal to 1. We consider r positive only, so r has to be equal to 1. We neglect the r equal to minus 1. Now, once we have r equal to 1, we substitute back here. That gives us cos theta plus cos theta equal to root 2. And from there we can say 2 cos theta equal to root 2. So cos theta equal to 1 by root 2. That's cos 45 degree. So we can say theta equal to 45 degree. Of course, other cases are also existing, but we will take 45 degree only. That's enough for us. Therefore, x equal to r cos theta plus r common I sin theta, and r equal to 1, and cos theta cos 45 degree plus I sin 45 degree. Well done. Now we want to compute x to the power 777. That's equal to cos theta plus I sin theta to the power 77. That's a big number. But you see that cos 45 degree, you have cos 45 degree here. If you double 45 degree, you get 90 degree. If you multiply it by 8 times, then you get 360 degree. Let's divide 777 by 8. 8 into 9 is 72. And then you are left out with 57. 8 into 7 is 56 and 1. So this can be written as cos 45 degree plus I sin 45 degree to the power 8 into 97 plus 1. Now we know that by De Moivre's theorem we can multiply powers with the angle. So we just multiply. First let's write it this way. Cos 45 degree plus I sin 45 degree to the power 8 into 97 into cos 45 degree plus I sin 45 degree. So we have just written this power 1 separately. That's it. Now if we multiply this out, we'll get cos of 8 into 45 degree into 97 plus I sin 8 into 45 into 97 degree. Let's write degree separately. Into cos 45 degree is 1 by root 2, and then sin 45 degree is also 1 by root 2. Now you see that cos, that is just 360 degree. 8 into 45 is 360 degree. 8 into 5 is 40. Yes, 360 degree. Cos 360 degree is cos 0, that's 1. Sin 360 degree is again sin 0, that's 0. Into 1 by root 2 into, once again, cos 360 degree is 1, sin 360 degree is 0, into 1 by root 2 plus I by root 2. So that's equal to 1 plus I by root 2. Yeah, and we are done. Oh, we are not done. Haha. We have just computed x to the power 177. But what about x to the power minus 177? That's equal to x to the power 777 to the power minus 1. That is 1 plus I by root 2 to the power minus 1. Again, that's cos 45 degree plus I sin 45 degree. And that's equal to cos minus 45 degree by De Moivre's theorem plus I sin minus 45 degree, and cos 45 degree, cos is an even function, so this is 1 by root 2, and sin is odd, so minus I by root 2. Lastly, x to the power 777 plus x to the power minus 777, that's what we want to compute, equal to 1 by root 2 plus I by root 2, that's x to the power 177, plus 1 by root 2 minus I by root 2, that's x to the power minus 177. You can cancel I by root 2, and 1 by root 2 plus 1 by root 2 is 2 by root 2. That's simply equal to root 2. And we are done. Yeah, at last we are done.